Good morning, students. The chapter 2 in physics in the Gauss theorem. The very important topic is Gauss theorem. In board examination 2021 in ISC examination, very important theorem. The firstly, what is the Gauss theorem? It state that the flux magnetic flux represented by phi is equal to 1 upon epsilon naught times of its enclosed charge. The formula is the phi is equal to q upon epsilon naught. That is called Gauss's theorem. In other words, we say that the magnetic flux is equal to the integrated of enclosed figure of a small quantity of surface area delta S or delta A. That is also called Gauss's theorem, according to Gauss's theorem. And now we prove that what is the Gauss's theorem. Let a sphere having a center is the q charge enclosed figure. So in center a particle of charge q, then a surface area, the small quantity of area then represented by different set of S or delta S. A intensity of work is the away the center E. The angle between delta S and E is 0 degree. The angle between surface area and intensity is 0 degree. Then the magnetic flux is also the small quantity of surface area and intensity. Then magnetic flux is also the small quantity. D phi is equal to ds into E. Another point, let a surface area ds and intensity of electricity intensity E work. Then theta is equal to 0 degree. Now second case, differentiate of phi ds into dE. Another case, same process, so on. Adding all the equation, then if small quantity added, then a bulk let it differentiate of integrate of overlapping means enclosed figure. When the sum of small quantity, then let write the integrate of the differentiate of phi magnetic integrate of magnetic field overlap of enclosed figure. This circle means overlap of enclosed circle. Then integrate of E dot S of overlapping of enclosed figure is the constant term. So using the identity of integration, the value of phi and E the constant term integration of ds, then E into S, whereas the surface area of a sphere or now E is equal to F upon electrostatic force upon Q naught, that is 4 pi epsilon 0 Q into Q naught upon R square into Q naught. Then the value of E is equal to 1 upon 4 epsilon naught into Q upon R square. That is the value of electricity intensity, and S is the surface area of sphere, CSA of sphere, that is called 4 pi R square. Both are value put in equation first. Then phi is equal to E 1 upon 4 pi epsilon naught Q upon R square, and S is equal to 4 pi R square. 4 pi R square, 4 pi R square cancel. Then Q is equal to epsilon naught. That is the proof and Gauss's theorem. It is the call of Gauss's theorem. Phi is equal to Q upon epsilon naught. That is called Gauss's theorem. Now we solve some numericals. The first question is the numerical. A point charge of 1.8 microcoulomb. A point charge of 1.8 microcoulomb is at a center of the cubical Gaussian surface of 55 cm side. Find the net electric flux through the surface. Then given is equal to Q is equal to 1.8 microcoulomb. The charges of 1.8 microcoulomb. 1 microcoulomb is 10 to power minus 6 coulomb. Now written 1.8 10 to power minus 6 coulomb. Then epsilon 0 is a constant value and given by 8.85 and 10 to power minus 12 coulomb into Newton into meter square. Find the magnetic flux. Find the magnetic flux in surface area. Then the formula of phi is equal to Q upon epsilon naught. Q is equal to 1.8 into 10 to power minus 6 and epsilon naught 1.85 into 10 to power minus 12. Then 1.8 into 10 to power minus 6 into 10 to the transfer the 10 to power minus 12 in the upper side, then the positive degree 8 minus 85 1.8 into 10 to power 6 upon 8.85. Multiply the 18 into 10 to power 5 into 8.85. Near about 2.01 into 10 to power 5. Total magnetic flux, that is called Newton meter square per coulomb. The unit of the flux is Newton meter square per coulomb. Another question is an infinite line charge produce an electric field of 9 into 10 to power 4 Newton per Coulomb at a distance of 2 centimeter. What is the linear charge density? And repeat question. An infinite line charge produce an electric field of 9 into 10 to power 4 Newton per Coulomb at a distance of 2 centimeter. What is the linear charge density? Then produces electric field, then formula of E is equal to pi upon lambda upon 2 pi epsilon naught into d, where the lambda is d is equal to given by 2 centimeter, written 2 into 10 to power minus 2 meters, and electricity field is 9 into 10 to power minus 9 to Newton per Coulomb, 9 into 10 to power 4 10 Coulomb, and then the 1 upon 4 pi epsilon 0 is the constant value 9 into 10 to power 9, then 4 pi epsilon naught 0 is equal to 1 upon 9 into 10 to power 9, then 2 pi epsilon 0 naught is equal to 1 upon 2 into 9 into 10 to power 9 Newton per Coulomb. That is the value of 2 pi epsilon naught. Find the value of lambda. Asking what is the linear charge density? Linear charge density, that is called the linear charge density. The lambda is called linear charge density. Find the lambda, then transfer the value. The value of lambda is equal to E into 2 pi epsilon naught into d. The value of E 9 into 10 to power 4 and 2 pi epsilon naught, the value of 1 upon 2 into 9 and 10 to power 9, then value of d 2 into 10 to power minus 2. Cancel 2 and 2, 9 into 9. Now the value of 10 to power 2 positive and 10 to power minus 9. The value of 10 to power minus 7 is as is written 1 upon 10 and 10 to power 6. That is called 1.0. That is called micro Coulomb. Coulomb per meter. Again, I repeat it. The question is, an infinite line charge produce an electric field of 9 into 10 to power 4 Newton per Coulomb. The electricity of produced 9 into 10 to power 4 Newton per Coulomb and at a distance of 2 centimeter. Distance equal to 2 centimeter in SI unit, 2 into 10 to power minus 2. And then 1 upon 4 pi epsilon naught is the constant value in value of in vacuum is 9 into 10 to power 9. Then 4 pi epsilon naught is equal to 1 upon 9 into 10 to power 9. Find the value of, because in formula using the 2 pi epsilon naught, 2 pi epsilon naught is equal to 1 upon 2 9 into 10 to power 9 Coulomb per Newton per Coulomb. Putting the value, find the value. Another question. A uniform charge conducting sphere of 1.2 meter radius at the surface charge density 80 microcoulomb per meter square I repeat, a uniformly charged conducting sphere of 1.2 meter radius and surface charge density of 80 microcoulomb per meter square. What is the charge on the sphere and the total electric flux leaving the surface of the sphere? Radius is equal to, the radius is equal to 1.2 meter, 1.2 meter, and surface charge density, surface charge density, the represented by nu, is equal to 80 microcoulomb per meter square. 1 microcoulomb 80 into 10 to power minus 6 coulomb per meter square. Then find the value total charge on the surface area. The charge is equal to Q is equal to the charge equal to density of surface charge into surface area, that is called sphere. Density is equal to nu into 4 pi r square, because according to the question r is equal to 1.2 meter. If then circuit is the sphere, then surface area of sphere 4 pi r square. Value of nu 80 into 10 to power minus 6. 80 into 10 to power minus 6 into 4 pi the constant, the value of 1.34, r is equal to 1.2 into 1.2. Multiply by the calculation 1.447 into 10 to power minus 3 coulomb. 1.447 into 10 to power minus 3 coulomb, that is called its charge. And second case, in second case, what is charge of the sphere and total electric flux leaving the surface of sphere. Asking total magnetic flux, that is called phi. Phi is equal to Q upon epsilon naught according to Gauss theorem. According to Gauss theorem, Q is equal to epsilon naught. The magnetic flux represented by phi is the formula of the Gauss theorem according Q upon epsilon naught. The value of Q 1.447 into 10 to power minus 3, and then epsilon naught is constant value 8.85 into 10 to power minus 12. 8.85 into 10 to power minus 12. Solve 1.447 into 10 to power minus 3 into 10 to power 12 upon 8.85. The 14.47 to 9 into 8, 1.85. The value of 1.64 into 10 to power 8 Newton coulomb per meter square, that is magnetic flux.